Round 3, hints for homework 2, part 3, 2 questions. Number 19, number 22. Number 19. Yeah. So this one is quite similar to one of the questions I talked about before. Yeah. But here, so let me just do another hint analysis to get you understand the method better. Yeah. All right, so let's look at the hint. Here we need to draw a diagram. So let's draw the diagram carefully. Data writes account for 10% of total memory accesses. Here, look at that. The base is memory accesses, not instructions. So that's the base. All right. So then when we draw the diagram, so we like to use base number 100. 100 memory accesses. All right. Then we know we should divide it into 2 parts. One part instructions, another part data transfers. All right. How much we may not know at this point. So we need to, try to figure out. But a data transfer divided into another 2 parts. Read part and reads and writes. Another 2 parts. Writes. Okay, all right. Now, let's look at the condition. First, 10% of the memory accesses data writes. So this part, 10. Okay, 10. Data reads account for 20% of the total reads. So what are the total reads? Total. All right, 2 parts. Instruction reads and data reads. All right. Data reads account for 20% of the total reads. Okay. How much percent of the instructions is for data reads? Okay. All right. So here you can see data reads. That's our target. That is our target. Can we assume X? Our target. Okay. Target. All right. So X here. All right. Data reads account for 20% of the total reads. All right. So 20% total reads. Yeah. 120% here. 80% here. Right? Yeah. 80%. 20%. That corresponds to X, 80% 4 times, right? So can we say 4X, right? Instructions 4X, okay? X reads total 100. So look at this, 100 equals 4X, the instruction part, plus data transfers, read part plus write part 10. How about that? That's the equation. Yeah. So when you do analysis, carefully draw appropriate diagram. Yeah. Using right base, that can make your expressions much easier. Yeah. Then try to, look at each condition, try to interpret each condition in the correct way. Yeah, here, yeah. And build some experience. So then you can solve this kind of questions. Yeah. All right, so that's number 19. Number 22. Okay. All right, so this one, the question is quite long, but it's not very hard. Yeah, it's pretty basic. Yeah. All right, so the hint. Here we we call it mixed cache. Okay, mixed cache. So we have data cache, instruction cache separately. All right, yeah. Okay, yeah. So then we know one thing. X% instructions are data transfers. So if we draw a diagram like this, here we use instruction as the base. 100 instructions. All right, yeah. So then X%, so X data transfers. All right, yeah. Then, because later when we use the formula for average memory access time, we need to calculate the miss rates. Okay, miss rates. So when we calculate the miss rates, we need to do one for data cache, one for instruction cache. The formula different. Try to use the right formula. Okay. All right. And we know the fractions. Yeah. So among all the memory accesses, the fraction for the instruction part, 100 over 100 plus x. The fraction for the data transfer part, x over 100 plus x. Okay, yeah, in that ratio, yeah. All right, so now we can represent average memory access time. Okay, so 5 clock cycle average memory access time. Okay, then 2 parts. When you write expression, part 1, part 2. Okay, part 1 instruction cache, part 2 data cache. Okay, all right. Then to combine them, yeah, we need to do the weighted average. Here we apply the weighted average. So why weighted average? Because the contribution from each cache different. Yeah, the contribution from instruction this weight, contribution from data cache this weight. Yeah. So that's why we need to put 100 over 100 plus x. That's the contribution from the instruction cache. Contribution from the data cache plus x. All right, yeah. Then inside the parenthesis, each individual average memory access time. Individual, okay? Yeah. Now you represent individual memory access time. average. Yeah. All right, so you know it. Yeah. All right, so now we can write that. Hit time, 1 clock cycle, 1 hit time plus. Now, miss rate. Miss rate with respect to instruction cache. How to do it? Okay. Number of misses, 5 instruction misses every 1,000 instructions. 5 every 1,000. Here, the denominator used that 1,000. Why use that 1,000? Because this cache can only take instructions, no data. That's why the denominator, we use all the possible memory accesses, but only instruction type memory accesses, no data type memory accesses. That's why denominator we put 1,000. All right. Yeah. All right. So the the miss penalty, right? The miss rate times miss penalty, 100 clock cycle. Okay. All right. Then data part. Okay. The same 1 clock cycle hit time data. Yeah. Okay. Then data misses every 1,000 instructions. Okay. All right. So the miss rate 50 misses. But this 1,000 instructions, we only look at the data transfer part. 1,000 instructions, only part of it correspond to data accesses. Yeah. So which part, right? Which part? X%, right? X%. So 1,000 times X%. Yeah. So here, X over 100, right? X%. Yeah. All right, so that's the number of data transfers times 100 miss penalty. So that's the equation you need to set up. Yeah. So try to understand. Yeah. Try to understand how do we split total memory accesses for instructions, for data transfers, then individual average memory access time. Okay, individual average memory access time. Okay, inside parentheses. But in the individual memory access time, you need to figure out the right way to represent the miss rates. Miss rates, mainly denominator part. Denominator part. How many total number of memory accesses with respect to that particular cache? That's the way you choose for the denominator. Yeah. All right, so a little more complicated. Yeah, a little more complicated. Yeah. Yeah. Hope you can understand. Yeah. From this video, you can understand why we set up equation in this way. Yeah. All right, so let me finish video number 3 right here.